So this is a continuation of the notes that we did in class today. Your homework is to just fill it out all the way to the end. If you guys want, you can fast forward to wherever we left off in your particular period. So today is note 7.3, day number 2. Objective today is to be able to find the composition of two functions. So we went over in class the different meanings of compositions. Basically what both periods came up with was a composition is when you put stuff together, which, you know, it's correct. So composition means put stuff together. What are we putting together? We're putting together two separate functions in this lesson. Now, in particular, in this lesson, the composition, it follows an operation similar to one we've done before, substitution. So if you had f of x equals 5x plus 1, and I told you x equals 2, basically what you would do was, since you know that x is 2, that's going to go in anywhere you guys see x. So what I taught you was put a blank spot anywhere you see an x, because that's what's, whoa, that's not an 11. Okay, because that's what's going inside of there. So, so 2 is going to go in for x here, and it's going to go in for x here. And then from there in, you would just simplify this out. So it'd be 5 times 2 is a 10, plus a 1, which is 11. So f of 2 is 11. So it's going to be similar to that in that I'm going to give you guys a value and you're going to plug it in. So let's go ahead and try this out. Gave you two functions, f of x equals 3x minus 1, h of x equals negative 4x plus 5. So the way you guys want to look at this, actually first off, the way it's read is f of h of x. Okay, so that is read as f of h of x. Now the first thing you guys want to look at is the function on the outside part, which is your f function. So you're going to write the f function, which is this 3x minus 1 piece. But instead of putting the x, I'm going to replace the x with a blank spot. The reason is because I know I'm going to substitute in, and I'm going to substitute into every single part that has an x. And that's the part that has the x. Now the next question that should be going through your minds is, okay, so what's going to go inside of there? Now if you look here, it has f of h of x. So if I would have told you f of 5, you would have put a 5 in for the x. But it's not a 5, it's the hx function that's right there. So the hx function is over here. It's this 4x plus 5 is h of x. So that's the piece that's going to go inside of the parentheses, negative 4x plus 5. All right, so you basically embedded the h of x inside of the f of x. Now you're actually done as far as writing out the composition, but you have to write it in simplest form. So standard form basically is what we're going to consider simplest form here. So standard form means you're just going to multiply it out, so you get the parentheses off of here. So this is 3 times this. You're going to multiply by 3. You're going to get negative 12x plus a 15. And then the minus 1 comes down to here. Combine your like terms. So it's going to be a negative 12x. Like terms are the 15 and the negative 1. 15 minus 1 is a 14. And you are done. Now, we're not going to worry about domain yet. We're going to cover that tomorrow in class, since you guys are having a little bit of problems with those. So for now, we're just going to do the composition. We're not going to worry about domains. So the next part says h of x, f of x. So the first thing you're going to write is the h part. So the h part is this 4x plus 5 part right there. So you're going to write equals negative 4. The x becomes the blank spot. So this x right here is kind of like your blank spot, or it is your blank spot, plus your 5. Now the part that goes inside of the blank spot is your f function. The f is going inside now. So that blank spot gets filled in with the 3x minus 1. So the x becomes the blank spot, and then you fill it in with the other function. Whoa, whoopsie. All right, so multiply. Negative 4 times 3 is a negative 12x. Negative 4 times a negative 1 is a positive 4. Then you're going to add 5 on. So that's going to be negative 12x. 4 plus 5 comes together, makes a 9. Those two are not like terms, so you cannot put them together. So there you go. Now, one thing I want you guys to kind of notice here is that we took two functions and we took the compositions of them. When the f came first over here, when you had the f on the outside and the h on the inside, you get a different answer than if you put the h on the outside and the f on the inside, which indicates that it does matter what order it goes in. So make sure that you put it in the right order. You won't get the same answer if you guys switch it around. All right, so this is what we do. Let's go ahead and do this one out. So f of g of x, so just like before, we're starting with the f function. So the f function is 3 blank spot -1. Our blank spot is this x right here. All right, take that off. All right, so g is this function over here. You're going to put that on the inside. So that's going to be a 2x minus 1. Now, like I said before, technically you are done making your composition, but you're not done writing it in the correct form. So the correct form is we don't want this negative exponent. So since this entire group right here has the negative exponent on it, you guys are going to use a negative exponent property, which means that the 3 stays on top. The part with the negative exponent moves to the bottom of the fraction, so it's going to be 2x minus 1 goes to the bottom. Now, so let me go and write this extra step in. Technically that turns to a positive 1, but anything to the first power is just the same thing again, so your answer is just going to be 3, 2x minus 1. That's your final answer. Now, some of you guys might be seeing that and you might know how to get the domain already. If so, see if you guys can find out the domain and check with me tomorrow if it is. If not, like I said, don't worry about it yet. We'll be going that more detail tomorrow. All right, so f of x. So it turns out you can compose a function with itself. So you start with the f function, which is this 3x minus 1 part over here. So you're going to write the 3, not minus 1, to the negative first power. 3 blank spot negative first power. Now you're going to fill in the blank spot with the function again. So it's going to be 3x to the negative 1 power. All right, so we have to do our properties of exponents. So put in your power right there. That's through the first power. So power of products says that I can take this and multiply it in. There is another method you can do where you can use a negative exponent property first. That's up to you guys. I'm just going to do it this way in the notes though. Notice that the negative 1 does not go over here to the 3. Okay? So you're not supposed to do that because this 3 on the outside is not, that once again, that is not inside of the parentheses. Right? So hopefully you guys didn't circle that because I just took it off. So that's going to be a 3. If you distribute, there are quotation marks, distribute, this negative 1 to that one, that's 3 times 3. A negative 1 times a positive 1 is a negative 1. X to the negative 1 times a negative 1 is a positive 1. Now, using the properties of exponents, you can do one of two things. Either you can use a negative exponent property, or you can use the product of powers property. I think the one I showed in class is that we went ahead and brought this one down to the bottom. So it's going to be 3 over, then that 3 moves to the bottom. X to the first stays on top. 3 divided by 3 is a 1. So 1 times x is just regular old x. All right. Next one, we do number 2. I think this is the one we left off in class with most of the classes. So g of h of x. So we're going to write g of x first. But remember, with your x's, you're going to put parentheses. Now, keep in mind, you have 2 x values there. So both of those should be replaced with blank spots. So you're going to write 3 blank spot squared plus 4 with a blank spot. Inside of those blank spots, you guys are going to put the other function. Your other function is h of x because it says that they want h of x on the inside right here. So you're going to put the x minus 2 in there. And then the 4 times x minus 2 again. And there you go. All right, so next part. We're going to simplify this. Make sure you guys take care of your exponents first. Now, you are not, so let me write this in red. You are not supposed to do this because there are 2 terms in there. You cannot do that. So let me take those back away. All right, so what you have to do is square that. So the square of x minus 2, basically you're going to do the x minus 2 times another x minus 2. So just multiply that out, and then you guys will get your answer. So let me write it down here. That's going to be 3 times the entire thing. So x times x is x squared. You're going to get a negative 2x and another negative 2x, which is a negative 4x, x squared. And then negative 2 times negative 2 is a positive 4. So it's 3 times that whole thing. Plus this 4 times this x minus 2 over here. All right. Let me move this over so. Okay, so now we got 2 distributions we got to do. 3 times all 3 of these terms, the trinomial right there. You want to multiply that by the 3. So that's going to end up being a 3x squared minus a 12x plus a 12. And then make sure you distribute this side too. So plus 4x minus 8. All right, so combined like terms is the last step. So you get a 3x squared. The negative 12x and the positive 4x make a negative 8x. Cross them off so you don't confuse them again. 12 and negative 8 can come together. That's going to be a positive 4. And that is the composition of the 2 functions. All right, next one, h of g of x. Not sure why that's way over there. Whoa, okay. So h of g of x, now I want to put the h on the outside, the x on the inside. Sorry, the h on the outside, the g on the inside. So first write your h of x function. So it's going to be a blank spot minus a 2. All right, you're going to fill that in with the g of x. Your g of x is 3x squared plus 4x. All right, so there's nothing really to do here, but take the parentheses off. That way you can combine if there was any like terms. To take the parentheses off, you can just drop them. But remember, the only reason why you're allowed to drop them is because you're multiplying by a 1. So it's going to be a 3x squared plus a 4x because you're multiplying by that 1, and then minus 2. No like terms, so that is your final answer. So that side was actually a lot easier. Okay, so we got a pair share. Yeah, pair share, and that's it. Okay, so the pair share. Let's see here. G of f of x. So you're going to write your g first. So let's see here. G is going to be 7 blank spot minus 3. So remember, this is your g function. And you are putting a blank spot on your x. So this will be, whoops, make this different color. So you want your f of x on the inside. F of x is this, so that's going to be your 5x squared. All right, so now we're going to multiply to get those parentheses off. Remember, you got one term inside of here. This is all one term. So you're taking this 7 and just multiplying it by the 5x squared. 7 times 5x squared is 35x squared minus 3. Big mistake I see a lot of people do here, they'll multiply this 7 to that 3. But remember, this 3 right here is not inside of parentheses. Okay? Whoa, I pushed something and I'm not sure what happened. Oh, anyways, okay. So, no, that's all. That's it. Okay, so 35x squared minus 3. Okay, next one, f function comes first, so you're going to get a 5 blank spot squared because that's your f function. What goes inside is your g function, which is this piece right here. So that piece is going right inside of there. So 7x minus 3. Okay, now comes into play the order of operations when we start simplifying this or putting it in standard form. So if we look at this on the, so PEMDAS, parentheses, exponents, multiplying and dividing have the same order, just from left to right, whichever one comes first, and then adding and subtracting. So we're doing PEMDAS because we're simplifying, not solving this. So parentheses, inside of the parentheses, there's nothing that really we could really do there. Those aren't like terms, so parentheses is out. Okay, next step is exponent. So we have an exponent right here. Be careful, do not do this. So do not write this down. Do not distribute the 2 like that. That is the most common mistake I see. That is a binomial. You cannot just distribute a 2 when you have a binomial like that. So what you need to do is actually write this out as a 7x minus 3 times another 7x minus 3. Now we did learn those special patterns if you guys are good with that and can multiply with those. But what I was finding out pretty fast in class was that a lot of you guys don't remember special patterns, so just go back to just the strictly multiplying. And if you catch on to it, then great. Okay, so you got a 5 times, so we're going to multiply all this together. 7x times 7x is a 49x squared. And we got a negative 21 and another negative 21. So that's going to be a negative 42x, and a negative 3 times a negative 3 is a positive 9. Okay? Um, just to re-go over the pattern is a squared um, minus 2ab plus b squared. So, but like I said, you can just multiply it out and get the same thing. All right, so next step, we're going to do 5 times 49. Oh, so 5 times 49, 9 times 5 is 45, carry the 4. 5 times 4 is 20, so it's 245 x squared. Multiply these. 5 times 2 is 10, carry your 1. 5 times 4 is 20, so it's 21 x. And then 5 times 9 is 45. All right, and that is your final answer, I hope. Is 45. Yeah, okay. So hopefully I didn't do that wrong. And 245x squared minus 210x plus 45. And then that, yeah, don't do that. We're going to do a workday tomorrow in class. So I'm not sure if these are going to be the numbers that I'm going to assign. So don't do those. Okay, so tomorrow in class I will be checking for these notes, making sure you guys got them, and then we'll do a workday. If you had any questions on this, make sure you note the time that it happened. That way maybe we can bring it up in class and then play it over and then see what happened. All right, okay, bye-bye.